where we are going to discuss solving inequalities involving absolute value. A reminder what absolute value is. It's the distance from 0 on a number line. It's always positive or 0, and we use those bars to indicate absolute value. In inequality, you're reminded if we have two numbers we're trying to compare, an inequality is what we use to compare them. Which number is bigger? The symbol would go this way because we eat the bigger number. 7 is bigger than 4. If we read this inequality from left to right, it says that 4 is less than 7. But if I read it from right to left, it says that 7 is greater than 4. So this symbol could be a less than symbol or a greater than symbol depending on which perspective we're looking at. If I have this inequality written, it says x is greater than or equal to -4. This is just saying any number we're talking about has to be greater than or equal to -4. This line underneath indicates an equal sign. So if we were to graph it, equal to means we could be equal to right at 4, so we need -4, so we need a closed circle. And all the numbers bigger than -4 would go off to the right. In this inequality, we don't have an equal to sign. It says that x is less than 9. When we go to graph it, we need an open circle. That just means that it can't be equal at 9. But this is where the graph starts, and all the x values go to the left because they are less than 9. This is what we call a compound inequality, and you can write it as two separate inequalities with putting the and in the middle, or you could put x in the middle, and it's sandwiched between -4 and 9. You just have to keep each symbol facing the same direction as x, so the only one that kind of gets flipped around is this one, where we have, if we read it from the x out, it says x is greater than or equal to -4. Graph this compound inequality. If we were to graph x is less than or equal to -2, the equal sign means I need a closed circle. Less than means we're going to the left. X is greater than 5. We need an open circle at 5 because there's no line underneath, and the graph would travel to the right. It's an open circle because there's no equal sign underneath the inequality. If we want to write a compound inequality based on the graph, let's look at the green portion. It starts at 1. It could be equal to, and the numbers get bigger from 1. So we would write it as x is greater than or equal to 1. And the blue one starts at -4. It's not equal to, but all the values are less than -4. We would put or in the middle because it means a solution could satisfy either inequality or both. The green graph describes x values that are less than or equal to 3, whereas the blue graph describes values that are greater than -8. The region that we graph, see how the points it comes together? Therefore, we put and. And means the solution would have to satisfy both inequalities at the same time. Meaning any number I choose, let's see, would -5 be a solution? Yes, it satisfies both inequalities at the same time. If you choose a number outside, it wouldn't satisfy. But we use and when you pick any number, and it's going to satisfy both inequalities at the same time. Solving for an absolute value inequality. Looking for a range of possible solutions. So this absolute value of x is less than or equal to 5 means where on the number line is the distance from 0 less than or equal to 5. Well, that's going to happen at 5 or -5. And if the distance has to be less than 5 units from 0, we're going to be above -5, but below 5. It's going to be coming together. So my two solutions would be x is less than or equal to 5 and x is greater than or equal to negative 5. It satisfies any number in these solutions would satisfy both inequalities at the same time. Therefore, we use the and. Notice, as you get rid of the absolute value bars, the inequality needs to flip for the negative number. If we have the absolute value is greater than 6, what this is saying is where on the number line is the distance from 0 greater than 6? Well, we're going to start at 6, so that means it's going to have to be greater than 6 or less than negative 6. What that graph would look like, less than negative 6 would be going off to the left from negative 6. We don't have an equal sign, so we leave it open. And the same thing on the right for the positive 6, open circle, and the graph would travel to the right. Let's take a look at this equation. Absolute value of x minus 3 is less than 6. Again, absolute value is the distance from 0 on a number line. So if we treat this the same, we're going to have a distance of less than 6. Well, it's going to be around 6 or negative 6. And so we can set each inequality. This side, we have x minus 3 is less than 6. This side, we have x minus 3 is greater than negative 6. Notice the inequality. When we set it equal to the negative side, we have to flip the inequality. We solve each one separately. So we get x is less than 9, add 3 to both sides, and x would be greater than negative 3. If we go to graph that, we have an open circle. Let's go back a moment. We have an open circle at 9, and our graph would be traveling this direction, whereas x is greater than negative 3, so again, an open circle at negative 3, and our solution would be coming this way. So if we wrote our solution like this, again, it's coming together, so we would put and in the middle. Here's a little more complicated inequality. Much like solving our equations, we need to isolate the absolute value. So we need to move the 8 over first, and then we can divide by 3. And now we have the absolute value of negative 2x plus 4 isolated, and it's going to be greater than or equal to 8. So again, absolute value is the distance from 0. So when is the distance bigger than 8? Well, we'd have to start, our starting point is going to be, well, 8 or negative 8, and that's where we can come up with our inequalities. Negative 2x plus 4 is greater than or equal to 8, or we have negative 2x plus 4 is less than or equal to negative 8. So again, the inequality must flip for the negative number. It doesn't have to be negative 8. In this case, it's negative 8, but in general, it's just for a negative number. We go to solve. We're going to have to subtract 4 on both sides. We can solve these at the same time if we choose to. We get negative 2x is greater than or equal to 4. On this side, we get negative 2x is less than or equal to negative 12. Divide by negative 2 on both sides. And we would have x is less than or equal to negative 2, and x is greater than or equal to negative 6. Notice, when we divide by the negative number, the inequalities flipped directions. That's something you learned previously, and it's something we need to be reminded of, that the inequality must flip when you divide by a negative number. If we go to graph, x is less than or equal to negative 2, we have a closed circle going off to the left. X is greater than or equal to negative 6, so we have a closed circle, and it's going off to the right. Things to remember: isolate the absolute value when solving an absolute value inequality. If it starts out like this, we'd have to subtract the 7, then divide both sides by 2 to isolate the absolute value. Absolute value is distance from 0 on a number line. So Anytime we have the absolute value isolated, we can set our inequality equal to the positive or negative solution on the right. So in this case, it'd be x minus 5 is greater than 3, or x minus 5 is less than negative 3. Flip the inequality for the negative value, or if you divide by a negative number in your process of solving the inequality. Graph an open circle for inequalities that don't have a line underneath. Graph a closed circle for inequalities that do have a line underneath.